Hey guys, what's up? My name is Avi and welcome to a brand new project on the TheCodex platform. This project is all about using sentiment analysis to understand financial news and make decisions on stocks. Every single day, authors around the world post articles, and Finviz is a great platform to see all the articles people have posted about a stock. What if, instead of having to go through every headline and understand is this positive news or negative news, we can use Python to parse finviz.com, gather all these article titles, and then use sentiment analysis to understand if every day averaging is this positive news or negative news. This is a very exciting project that'll use a whole bunch of different technologies. We'll start off with beautiful soup on Python by scraping the website, gathering the data, and then using pandas to analyze and run our NLTK module for sentiment analysis, and then last but not least, matplotlib for visualization. At the end, we'll have this final graph where you can specify what tickers you want to visualize, and we can see the correlation and sentiment analysis average daily of how that stock has performed based on the news. This will be a great project to kind of hone in your skills on web scraping, on data analysis and manipulation, and last but not least, visualization of the data. Hey guys, what is up? Avi here and welcome back to TheCodex. In this video, we're continuing our new project on sentiment analysis of stocks from financial news. And in this video, we're going to be using beautiful soup to parse Finviz, an online financial data company, and get the headlines of articles based on tickers of our choosing. So what does that actually entail? Our goal right now is to accumulate as many headlines as we can, and then after that, run sentiment analysis on the text of those headlines. Finviz has headlines of every relevant ticker that we can search for over here. For example, on finviz.com, I can go ahead and type in Amazon. I can open up the ticker, and this has a bunch of numerical data about their market cap, income, all that good stuff. But then down below, I can actually see, if I zoom in here, I can see the articles that is the most relevant to me. So these articles are again in the HTML source code, and we can use beautiful soup here to parse that code and get these articles of our choosing. So if I go ahead and view page source, and now if I search for AWS and Formula One, this text corresponds to this link right over here. And so our goal in this video is to parse this HTML code and get the relevant titles and the timestamps in order to parse and apply the sentiment analysis on. So without further ado, let's jump right in. First thing first, we're gonna go ahead and open up a brand new project in PyCharm. Again, if you're using a different editor, feel free to use anything of your choosing. I use PyCharm because it's something that I've been using for multiple years. And over here, I have a folder already created. I'm gonna create a new Python file called main.py. Now inside of this file, for now, I need two modules. I need the request module, and I also need my beautiful soup module. So we're gonna go ahead and import two things from url lib.request, import url open, request. And then second of all, we're gonna go ahead and import from bs4, import beautiful soup. Now I'm sure one of these modules you might have to install. And if that's the case, head over to your terminal. And inside of your terminal, you're gonna go ahead and type in over here, Python 3, that is the version of Python that I'm using. You might be using Python 2. In that case, type Python or just Python 2. And then go ahead and say -m pip install bs4. So what does that command look like in its entirety? We can see Python 3 -m pip install bs4, and that will go ahead and install beautiful soup 4 on your machine. If that works, then you should no longer see an import error when you say from bs4 import beautiful soup. The next thing is our URL. So what is the URL of our choosing? Well, as you can see over here, when we passed in the ticker name, for example, Amazon, it goes ahead and passes in the ticker as a parameter in the URL itself. So simply, all we have to do actually is take this URL of https finviz.com/quote.ashx $t equals, and then we can pass in any sort of ticker symbol to get those results. So in this case, if I do Amazon, that's Amazon. Otherwise, if I do something like AMD, for example, I can get the relevant AMD data, etc. So I'm gonna go back over here and type a new variable. I'll call this Finviz URL for now. And inside of this, just paste the Finviz URL that we just copied. Now, in this case, it might differ a little bit. You might have a different variable name. That's totally fine. But this is the raw kind of URL that we're looking for. And now let's go ahead and come up with a list of tickers that we want to parse in this project. So I'm going to go ahead and create a list of common tickers that I frequently check, including Amazon, including AMD. Let's go ahead and add some more common ones like Facebook. And I think for now, that's fine. So Amazon, AMD, and Facebook, these are 3 fantastic companies that you can look at the stock data and get the financial news from. So here, I'm going to go ahead and now iterate over each of these tickers and create the Finviz URL that we're going to go ahead and parse. So for ticker in tickers, I'm going to go ahead and say right over here, my URL that I'm going to parse, my actual kind of call here, is going to be equal to my Finviz URL plus whatever ticker is chosen. So here you can imagine that my ticker Amazon, AMD, and Facebook will just be appended on, and that will complete my Finviz URL that I want to go ahead and get the HTML data from. Awesome. Now that we have our URL that is completed with the Finviz URL plus our ticker, our next step is to go ahead and request the data from this URL. Now we imported at the top URL open and request, and these are the 2 modules that we're going to go ahead and use to open up this completed URL and request the HTML data. So go ahead and create a request variable, and inside of this specify you're using the request that we imported from above. You're going to specify the URL parameter, which is equal to the URL we just created. And then after that, you're actually going to specify a header, and this header will allow us to access this data. If you don't specify a user agent, then we will be forbidden access and we won't actually be able to download the data from our finviz.com website. So in this user agent, you can specify your application to be whatever name it is, but you're essentially just verifying that, hey, I'm accessing this website from this particular user agent. In this case, it can just be my app. So that is my request. And now I'm going to go ahead and open this request by saying response is equal to URL open, and then pass in this request. So now I'm going to go ahead and just print out the response and see what happens. We're not going to see anything exciting, but we'll go ahead and just see a request side of object. So we have an HTTP client, HTTP response object, and this is something that Beautiful Soup can now take in and parse the HTML content out of. So imagine that we now have the response of this entire website with the ticker being passed in. And the reason why I added this break is so that I don't go through all the tickers since we're only testing this code as of right now. And what I'm going to go ahead and do now is take this response and throw it into a Beautiful Soup. So I'm going to say HTML, my actual HTML code here, is equal to Beautiful Soup, pass in the response, HTTP response we just got, and then mention that it's an HTML parser that we're using. That's all we have to do. And now if I print out the HTML code, we're going to see exactly the source code that we want to go ahead and get from this website. So this view source code that you see over here, we will now see in the output of the terminal. If I go ahead and zoom out just a little, if you can kind of visualize that, it's a lot of different code and a lot of different things are going on, but I hope you get the gist. We're now parsing the HTML code from this URL, finviz.com/quote, where the parameter is now Amazon, AMD, or Facebook. Now I'm going to go ahead and go back to this sort of page and search for AWS and Formula One and see where this data actually lies. And if we take a look over here, we notice that all of these articles lie in this table. And let's go ahead and kind of look at the HTML code to figure out what we can use. We can see that a table holds all the data, and that table has an ID of news table. So what we can do is we can take all of these news articles, parse the table by ID, so news table ID, and then just add this data right now to a dictionary that we can parse down the road. So let's go ahead and do just that. I'm going to go ahead and create a dictionary above this for loop and call it news data. And inside of this, I'm going to go ahead, or actually, you know what? Let's use a better word. Since these are tables, let's just go and call them tables. News tables is an empty bracket kind of dictionary. And then right after that, we're going to go ahead and use some Beautiful Soup syntax in order to parse this HTML and get the ID news table of this entire HTML object. So over here, I'm looking for the news table ID. I'm going to go ahead and say my news table is equal to html.find. And here I'm going to specify my news table ID. Again, the exact same ID we found in the source code. Go ahead and specify news table. And so what this is going to do is it's going to get us the HTML object of this entire table. So however far down this extends, like a huge, gigantic table with all the different results, this is exactly what we want. We're storing this right now in terms of our news table dictionary. So we're going to say over here, our news tables dictionary has a key. That key is going to be the ticker value, and that should be equal to the news table that we just added. So again, all we're doing right now is we're taking this table object and storing it in a dictionary. Yes, it's a little bit inefficient. We could definitely parse through every single table right now itself, but kind of to simplify the code and make it easier to understand, let's save these tables to a dictionary and then parse each table individually. So now that we've done that, let's go ahead and print out our news tables and see what's up. So I'm going to go ahead and run this code. I can see a small wording over here, which is just saying a beautiful soup message. And now this dictionary holds just the table of my results from the web page. And so all these TR links, again, TR in HTML stands for table row, all these table rows correspond to all the table rows that we see over here. Each one of these is a table row, and we can now parse the table row to get the text of each of these sites. Hey guys, Avi here, and welcome back to TheCodex. In this video, we're continuing our sentiment analysis of stocks from financial news. And in this video, we're going to go ahead and parse the data that we've gotten from Beautiful Soup and get it into an understandable format that we can extract the title, the timestamp of these news articles, and then eventually apply our sentiment analysis on. So the goal of this video is very simple: to iterate over all these table rows that we can see in our data set and get the values of not just the timestamp, but also, if I can scroll over here, let me go ahead and move this a bit faster. We have the href of the link, but then also the text of every single article that's in the table. So let's go ahead and first understand how we can do that with a simple base case. And then after that, we'll go ahead and expand to a more globalized function. So right now, I'm going to go ahead and access my first kind of index, which is news tables Amazon, as a play data set. So I'm going to go ahead and say over here, my Amazon data is going to be equal to my news tables Amazon. And now I'm going to go ahead and find all of the table rows that are relevant in this table HTML object. So there's a very cool find all function that Beautiful Soup has. And what I can go ahead and do is say that my Amazon rows is equal to my Amazon data dot find all. And then here I'm just passing in the HTML tag tr. And so what it's going to do is give me a list of all the different tr elements inside of the HTML object I just passed in. And in this case, I passed in the table of all the relevant news articles. So what I can go ahead and do now is print out my Amazon rows just to give you a quick rundown of what's going on and what's happening over here. So if I go ahead and Control-Shift-R, it's going to go ahead and parse the website. And now I have a list-like object where I have all my TRs in a comma-like fashion, and I can now go ahead and iterate over these rows to get the values. So for a quick demonstration of that, and feel free to just follow along, you don't have to copy this code. This is more optional just to understand the data of the rows. So we have all the table rows of our table, and now what I'm going to go ahead and do is iterate over these table rows. So for index, comma, row in enumerate Amazon rows. So again, the enumerate function gives me the index and the object of any list item or of any list, and it iterates through every single object. I'm going to go ahead and get the text of what. What exactly am I looking for here? So I notice that there is an A tag inside of my TR. And if I scroll to the right, I can see that inside of that A tag is the actual text of my article. So I can go ahead and say over here that title is going to be equal to my table row. So in this case, row. And then I'm going to access the A attribute or the A tag inside of that. And then I'm going to get the text of my anchor tag. So all I'm saying here is that look for the anchor tag inside of my table row. And this anchor tag that I can see right over here, go ahead and give me the text that's inside. And so that should give me this text right over here. And then I can go ahead and take a look at what this does. So let me go ahead and just print out the title for now, just to show a quick example of what's happening. So it's going to go ahead and parse the HTML code, and look at that. I'm now able to get the text of every single article of the table row inside of my massive table. Now let's go back and see how we can get the kind of date or the timestamp over here. So I'm going to go back to the HTML code and let's take a look at what's happening. And I can notice immediately that kind of like how we had our anchor tag, and inside of the anchor tag, we had the text for the article, I'm noticing that we have this TD tag, and inside of the TD tag, I'm seeing the actual timestamp. And so what I can go ahead and do now is search for the TD element and look for the text inside of the TD element to get the timestamp of our data. So that seems very straightforward. Just like we have title, I can say timestamp. My timestamp should be equal to row.td.text. So again, now we're looking for the TD element and getting the text of that. And now, for simplicity's sake, I'll just go ahead and say print timestamp plus, and then a space, and then title. So let's go ahead and run this, and let's see what we get. Here is our code, and awesome. I can go ahead and see immediately that I have the timestamps of when every article was published. I also have the relevant date for when it's the start of a new day. So the next step is to go ahead and take this code and modularize it so it works for any ticker inside of our data set. Right now, this data is very test focused. It's more of just testing out Amazon and making sure that the data works. So let's go ahead and iterate through the news of all of these kind of news tickers that we're going to populate. And then let's go ahead and scrape the data and add it to a new list of items. So let's go ahead and run that code right over here. I'm going to create a new data structure called parsed data. And this is going to be a list object. And my goal right now is to just create multiple kind of lists of lists, or just like lists inside of this data set that correspond to my ticker, my date, my time, and the title of my article. So now we're not too worried about storing them based on ticker. We're just going to store all the data we can get on all of our different tickers inside of just one massive array. So let's go ahead and iterate over our dictionary. Our dictionary over here was called news tables. So for file or for ticker, comma, news table in my news tables.items. So I'm iterating over the key and value pairs for every single key value in my news tables dictionary. What I'm going to go ahead and do is kind of copy the same code we had above when we were doing test it, which was for every single kind of rows, for all the rows in news table.find all, and we're finding all here the TRs, right? For all the rows that we can find, what are we doing? We're trying to scrape multiple things here. The first thing was, can we scrape our title? So we know that the title of our article is equal to whatever row that we get. Sorry, I should actually make this singular because we're iterating over every single row. So title here should be equal to row.theanchortag.getText, right? So something very straightforward. And then the next thing is to go ahead and get our kind of timestamp. So the timestamp here could either be of two formats. It could be of a single timestamp like this, or a timestamp with a date. So let's go ahead and implement both cases. We're going to go ahead and say that our date is going to be equal to row.td.text.split. And what this is going to go ahead and do is split our text based on, in this case, a space. So over here, we're saying that split this into sections, and we're going to go ahead and see that if the length of this is only 1, then we know for a fact that it's just a single timestamp. But if our length of this date is greater than 1, then we know for a fact that there's multiple values here. The first value is going to be our date, and the second value is going to be our time. So we can go ahead and do that right over here. And you might notice I use get text instead of text. They're essentially the same thing. I can go ahead and say text and we get the same results. But over here, I'm going to say that if the length of my date is equal to 1, this implies that we only have the timestamp. Then I'm going to go ahead and say that the time data is going to be equal to my date. And I'm going to go ahead and say the first value. So again, we're splitting by the space. We have split the date. And we're saying that the first item, so the first item over here, should be my time. And otherwise, if we have more than one component, something like this, June 1820, 9:28 p.m., then we have two components. We have the date and the time. And so I'm going to go ahead and say over here that my date should be equal to my, actually, I'm going to reword this. I'm going to call this date data. That way we can distinguish between date and the actual date data. And I'm going to say my date data is going to be 0 and my time is going to be date data 1. So hopefully that makes sense. All we're doing is we're getting this text right over here and we're splitting it up based on the spaces. If there are two components, or if there's essentially just not one component, then we know we're dealing with two components here. The first one being the date, the second one being the time. Otherwise, if the length is equal to 1, then I know we're only dealing with one component, and that is this timestamp, which is time, date, data, 0. So now that we have our title, our time, and our date, the last thing is our ticker, and we have that right over here from iterating over through the items. And so all I'm going to say is, for each one of these rows, we're going to go ahead and say parse data dot append, and we're appending inside of this ticker, the date, the time, and the text. All right. So again, all we're doing is we're saying, sorry, not the text, the title. And we're saying that if the date exists, then we'll go ahead and add that date in, the time in, the title in, etc. And if it doesn't, no worries. And over here, I'm going to do this small issue, date not defined, because I need to replace date data with that right over there. Go ahead and save this. And at the very bottom, print parse data, and let's see what we get. So let's run this code, and I see our ticker, and let's take a look. So we have right here our first value, Amazon, the date, June 23rd, 20th, timestamp 409 with some external kind of, I believe the and NBSP that we can go ahead and remove down the road. That's fine. And that was our first article. Let's take a look at the second one. Amazon, June 23rd, 1:30. Amazon, June 23rd, 12:46. Here's the title. Fantastic. So what we've done in this video, guys, is we've taken our data set, the large conglomerate of tables and all these table rows, and we've parsed through that and found exactly what we needed. The ticker, the date, the time, and the text. Hey guys, Avi here, and welcome back to TheCodex. In this video, we're continuing our project sentiment analysis of stocks from financial news. And in this video, we're going to apply sentiment analysis on the titles that we got in the last video. So right now we have a list of lists, and each list consists of a ticker, a date, a time, as well as the title of the article. And our goal right now is to take every single one of these titles and apply sentiment analysis. So in order to do this, we're going to look into something called Vader, which is part of NLTK corpus. Again, a lot of buzzwords, but let me break that down for you. So go ahead and search NLTK Vader sentiment. And this is an online package that's been trained on a bunch of online articles. There's like a whole kind of documentation on what it does. But essentially, we can use NLTK's type of corpus for Vader to apply sentiment analysis on code. So what does that mean for us? Let me go ahead and pull up this link to show you an example of how this works. I'm going to go ahead and kind of just like read off this for just a second and give an idea of what's going on. So you import this kind of function, sentiment intensity analyzer, and then all you have to do is take some message text. For example, I'm getting frustrated with this process. I'm genuinely trying to be reasonable. You apply polarity scores on top of this message text, and then you're given out kind of positive, negative scores. So the result that we get from applying this function on the text is compound negative 0.3, negative 0.093, neutral 0.836, positive 0.071. So what does this result mean? Well, the negative, neutral, and positive values describe the fraction of weighted scores that fall into each category. So we have like it's a part negative, part neutral, part positive, but at the end of the day, we care, is it negative, is it positive, or is it somewhere in the middle? And that's where the compound part of the result comes into play. The compound portion is a normalized value between -1 and 1. And this value attempts to describe the overall effect of the entire text from strongly negative, which is -1, to very positive, which is +1. So this -0.3 signifies that this text is moderately negative. And that kind of makes sense. You see words like frustrated, he's trying to be reasonable, I'm not trying to hold up. This seems like kind of a semi-negative text. And so our goal is to apply this function from NLTK's module on our titles that we've parsed over here. So at the very top of your code, we're going to import a couple of things. The first thing that we're going to import is NLTK. And what that means is you have to install that. So head back to terminal, and inside of terminal, go ahead and type python 3-m pip install and then NLTK. Okay? And so it's going to go ahead and install NLTK on your machine. And then in Python console, this is something unique. Again, if you don't have Python console open and you're in terminal, go ahead and just type Python 3. You're going to do two things. You're going to say import NLTK, and that will go ahead and import the corpus. And then you're going to say nltk.download, okay? And inside of download, you can specify that you want to download the Vadar lexicon package, or you can use the nice graphical interface that download comes with. So it goes ahead and creates this pop-up, and this pop-up allows us to see what packages NLTK has and what we can use. And so we're trying to use this sentiment analysis package called Vadar. So if I go ahead and go to all packages and essentially scroll down until I see V, I'm looking for Vadar, and that is this package right over here, Vadar_lexicon. So go ahead and double click on that and install or download, and that should go ahead and install it on your machine. And that's that. Now, again, if you don't see that graphical interface pop up or you run into errors, you can also just say nltk.download and then pass in quotation marks, your Vadar_lexicon. So again, both work, and that should install the package on your machine. Now at the very top of main.py, you're going to go ahead and import this package. So you're going to say from nltk.sentiment.vadar, we're going to import sentiment intensity analyzer. And so this will allow us to call the function we just saw in the article and apply sentiment analysis on any given text. And last but not least, at the very top, I'm going to say import pandas as PD. Now, pandas is a module that allows us to manipulate data in a nice table-like data structure. It's very popular in data science applications, and the reason why we're using this is because pandas will allow us to very quickly apply functions, for example, in this case, a sentiment analyzer, onto our data set. And so go ahead and say import pandas as PD. We have our imports ready, scroll all the way down, and now let's go ahead and start implementing our code. So the first thing first is we're going to create a data frame to host our data in. We have this array collection or data structure. It's not the best, it's not very efficient. So what we're going to go ahead and do is create our pandas data frame, df, and set this equal to pd.dataframe, pass in our kind of parsed data that we have already, so a list of lists, and we're going to specify a columns field. So the columns are going to be the headers of our table. Imagine this to be an Excel spreadsheet. It's our data frame. We have our ticker, our date, our time, our title, but Pandas doesn't know what the actual columns are called. So go ahead and inside of this, pass in an array for each one. Ticker, date, time, and then title. So these are our 4 column names for our Pandas data frame. Now we can go ahead and for now just print out our head, print df.head, and this will print out the first 5 rows of our Pandas data frame. So go ahead and run this for now. Let me go ahead and show you the results over here. And there we go. So it's kind of condensed, and honestly, if you were using Jupyter Notebook or a better visualizer, this would look a lot cleaner. But for now, I just want you to understand that we have this type of like row by column structure where we have rows, there's tickers, there is 2 other columns in between over here, and then the title. So that's essentially what I want to show you is now we have this in the data frame-esque object. Now the next step is to go ahead and initialize our Vadar. And Vadar here is the sentiment intensity analyzer. So go ahead and specify here, Vadar should be equal to sentiment intensity analyzer and call that function. So Vadar will be used to analyze any given text. How would this work, or what's an example of this? Let's go ahead and just test this out. So I'm going to say Vadar, so print out Vadar.polarity scores, and now pass in any text. I don't think Apple is a good company. I think they will do poorly this quarter. So this is again some sample text. I don't obviously believe this, but go ahead and just run this and let's see what happens. And I want to give you an example of the Vadar polarity scores. So as soon as that ran, we can see over here that -0, neutral 0.8, positive 0.195. Interesting. So the module isn't perfect, but it does give us a good unbiased estimate of what the text is in terms of positive words or negative words. And I guess in this case, it probably picked up the word good and countered that with poorly and must have come up with a compound score of 0.4. let's go ahead and throw in some negative words. Let's go ahead and rephrase this. I think Apple is a bad company and they will fail sales this quarter. I don't know, something a little bit more negative. And let's run this and let's see what happens. So again, running the same text on the scores, and now we see a little bit more negative. Negative 0.412, neutral 0.588, but the compound score, which we really care about, is negative 0.79. So that again it's looking for the bad kind of negative correlated words, bad, fail, etc. And again, it's not perfect, but it gives us a very good idea of what the sentiment is. And I guarantee you this is industry standard. So it's very popular, used by a lot of professionals and scientists. And I would say here that for the case of this project, it fits our case perfectly. So let's go ahead and apply polarity scores on what? On the title column of our data frame. So if I go ahead and print out df title, I can access all the titles of my data frame and see over here the 99 plus different titles that exist. And so what I'm going to go ahead and do is enter in some cool pandas magic. And I'm going to say over here that my df create a new column. I'm going to call this column my score, or for now, let's call it compound. And this compound score is going to be equal to my current data frame. I'm going to apply this Vader function, the Vader.polarity score function, on the title column of my data frame. So what we're doing is, I'm going to go ahead and type it out here. I'm going to take every single title and I'm going to apply a function. And the function I'm going to apply is going to be a lambda function. So if it's a little bit easier, let me go ahead and explain separately what the lambda function is going to be. I'm going to call this lambda function f, and this lambda function is going to take in a title. The title is going to be x, or for simplicity's case, I'll say title. And it's going to say, give me the polarity score of this title, except I don't care about all the values. I don't care about positive, negative, neutral. The only value I care about in that dictionary object is going to be the compound score. So go ahead and say that, okay, for whatever string I pass into this function, if I call f on any string, ASD, I want you to just give me back the compound score. And so now I can apply this function f on my df title. So for every single title that exists, I can go ahead and apply this function on it. And what I'll go ahead and do is create a brand new column inside of my data frame called compound with just the compound scores of the sentiment analysis of every single one of my titles. So now if I go ahead and print this out, let's go ahead and say print df.head, and let's see what happens. So over here, I have my terminal, and would you look at that? Now we have 5 columns, and I'm sorry that you can't see the ones in the middle, but just take a look at the last column we just added. We're now able to specify, with the beauty of pandas magic plus some neat lambda function, that every single title now has the corresponding compound score associated with it in the column right next to it. So what we've essentially done is we've taken our data, applied the polarity score, the sentiment analyzer, on each one of the titles and added it as a column in our data frame. Hey guys, Avi here, and welcome back to TheCodex. In this video, we're wrapping up our sentiment analysis of stocks from Financial News project. And in this video, we're going to go ahead and take a look at visualizing the data that we have parsed and analyzed so far. So we've done a lot. We've gotten the data from Finviz using Beautiful Soup. We've parsed that data to get the relevant title and information. We have applied sentiment analysis to figure out how positive or negative the titles are. And now let's visualize a trend over time to see how this company or how the companies we've chosen have been faring. So first thing first, I want to go ahead and convert the date from a normal string to a recognizable date time format so we have a hierarchy of what date came when. So let's go ahead and do that right over here. I'm going to say df and then pass in the date column. So we're modifying the date column to be, and then say over here, pd.toDateTime. And we're going to go ahead and specify which column we're making the date time. We're saying the df.date column. And essentially, all we have to do is just say .dt.date. And what this will go ahead and do is take our kind of date column and convert it from string to the date time format, okay? And that way, when we visualize this in Matplotlib and draw the chart, we'll make sure that the months of May, June, whenever this video is being recorded, the months of May and June, they'll come in the correct order. And the datetime object pandas in Matplotlib automatically recognize. Now the next step is to go ahead and import Matplotlib to visualize this data. So at the very top, I'm going to go ahead and say import matplotlib.pyplot as PLT. Now, again, if you don't have Matplotlib installed, go ahead and install it in your terminal. So you're going to go ahead and, let's go ahead and exit that. Exit, there we go. And over here, we're going to go ahead and say just one thing, python 3-m pip install matplotlib. So again, if you don't have this package installed, make sure you go ahead and install it right now. And that should go ahead and install that on your machine. Once that's done, and we've imported matplotlib.pyplot as PLT, the next step is to go ahead and set our figure size. So the figure that we're going to be making today for now, we can set it to be equal to fig size 10,8. This can change down the road. And now our goal is to take all the compound scores and get the average of them. So what does that mean? I have all these articles over here. For example, I'm looking at Amazon data, June 22nd. I have 5, 10, 15, 20, all these different articles. And each one of these articles is going to have a compound score associated with it. That compound score is a sentiment analysis ranging from -1 to +1. I want to average all the scores of all the news articles every single day to figure out, was today a positive day for Amazon or was today a negative day? Or maybe it was neutral. So we're going to use some cool pandas techniques to analyze our data frame, get that going, and then visualize that and plot the data out. First thing first, I'm going to call this a new mean df, and we're going to go ahead and group our data by ticker. So again, Amazon, AMD, Google, etc., and then the date. And so by grouping it like such, I'll have the Amazon date specific, all these collected together, and then I can essentially just calculate the mean. And what this will go ahead and do is look for integer values. And the only integer values we're dealing with right now are the compound column values. And so the mean function, when applied on this group by, will go ahead and return me a data frame where I have the column ticker, the column date, and then all of the compound values mean or averaged so that we have one value for every ticker date specified. So that's the power of group by specifying mean. If I go ahead and just print this out, print mean df, let's go ahead and see what that looks like, just for visualization purposes. And I think in hindsight, I should have used a Jupyter notebook to visualize this data since I'm doing so much work with pandas, but in future projects, I'll definitely implement that. In this case, I have a ticker, I have the date, and now you can see that I only have one date entry since we use the group by function over here. And by calculating the mean, I have the average sentiment of what the average article kind of said. Was it a positive? Was it a negative? Was it kind of neutral? And for the most part, Amazon has been relatively positive up until the past couple of days. So what we can go ahead and do now is modify this data frame so that it will follow kind of the chart-like data structure that we need to visualize this. The first thing is we're going to go ahead and unstack this data. And unstack will allow us to have kind of the dates as the x-axis. And so we're going to say over here, mean df is equal to mean df.unstack. And then right after that, we're going to get rid of the compound column. And when I say get rid of that, I'm essentially just removing the name compound. And so I'm going to go ahead and say over here, mean df is equal to mean df.xs. I'm going to take a cross section. The cross section is going to be of compound. And then I'm going to go ahead and specify my axis to be columns and then transpose this data. So this is doing a lot of kind of nifty pandas techniques, but essentially all I'm doing is manipulating this data frame over here, transposing it, and ensuring that I get exactly key value pairs being the dates and the compound values for every single ticker. So if I were to print out what this mean.df looks like after applying these two functions, let's take a look at that and see if this data kind of represents what we want. So in this case, I now have my ticker and I have Amazon, and now I have my dates as my first column and I have the values as my second column. So that's the power of taking the cross section. If I don't take the cross section and I simply just transpose, let's take a look at what that looks like. And you'll see that I'll have an extraneous compound column that I don't need. This compound column exists because of the group by and unstacking, and by simply taking the cross section, I can get rid of this extra type of label that's being added on my data set. So now that I have this mean df and it seems to be looking good, the last thing I have to do is plot this. So I'm going to go ahead and say mean df.plot and specify over here that it's going to be a bar chart. And now the last line for this project, plt.show. So this will go ahead and render my entire plot on my screen. And I think in PyCharm will show it kind of nicely on the right hand side. But again, if there's one thing that you forgot, it's the very top. I had a break statement to ensure that I don't go through all my different tickers to save time and efficiency. But go ahead and remove the break statement in case you had that. Now go ahead and run this code and let's visualize our entire project end to end. We analyze the Finviz data, we run sentiment analysis, and now in hopefully a nice rendered bar chart, we can see this data over time. So over here, let's go ahead and take a look at what's going on. I'm going to zoom in. Here I can see my bar charts going from -0.2 to 0.3. The blue lines represent AMD, orange is Amazon, FB is green. Now I guess AMD doesn't have a lot of articles, and that's why I have so many data points. Instead, what I'm going to go ahead and do is remove my AMD ticker and replace this with something that I believe is a bit more popular. So let's go ahead and try Google and see how this data set looks. So I'm going to go ahead and run this one more time so that our data set is a bit more cleaner. All right, so this definitely looks much cleaner than before. And let's break this down. So I have my 3 tickers, Amazon, Facebook, and Google. And every single day I can see if articles were published, what the sentiment of these articles were, the average sentiment of these articles. So going by recency, I can see that these dates are now in the correct timestamp format because we converted the dates to the date time format. And in the most recent date, there was some negative news for Amazon, positive for Google. Yesterday was a very positive day for Amazon, and we can see a general trend of negative news for Facebook. And hopefully that corroborates with the data that we see if we read these articles and take a look at what's happening. Are these negative or positive articles? But that was our project end to end. We started off with simply a data set, not even a data set, a URL. Our goal was to take these Finviz articles, analyze them, and figure out every day, is my stock having positive news associated with it or negative? And that's exactly what we did. To break down what we've accomplished, I think it's pretty impressive. We took our article, we iterated over the tickers and got the HTML data. We parsed this HTML data into a format that was nice and readable, applied it to a pandas data frame, and calculated the sentiment analysis using Vader. And last but not least, we visualized this data set in a bar chart-like format to see how our stocks have progressed over the course of the past week and see the relevant kind of highlights of the positive and negative correlation of sentiment analysis. I hope this was an interesting project for you. I know I've had a lot of fun building this. There was a ton of cool technologies that we played around with, and this is definitely a script that you can run every day perhaps and see how your stocks are faring and make trades based off this information. Thanks so much for listening, guys. I hope you've enjoyed this project, and I hope to see you in a future project down the road on the TheCodex platform. Thanks so much.